Right now, your body is quietly eating itself, not metaphorically, not as a warning, literally. At this exact moment, your cells are dismantling pieces of themselves, stripping damaged proteins, recycling broken parts, and using the debris as fuel. And the unsettling part? Most of you have been spending years, accidentally stopping this process from doing its job. 3 meals a day, a late night snack, a protein shake at 10 p.m. Every time you eat, you shut it down. Every single time. The process is called autophagy, and it may be one of the most powerful biological mechanisms your body possesses. It won the Nobel Prize in 2016. Researchers have linked it to longevity, cancer prevention, neurological protection, and metabolic repair. And yet, almost no one is talking honestly about what it actually takes to turn it on. Not the Instagram version, not the just skip breakfast version, the real, scientific, cellular version. Because here's the thing nobody tells you. The fasting window most people use isn't enough. Stay with that. Picture your cells like a city, a massive living city, billions of buildings, endless traffic, constant construction and demolition. Most of the time, this city runs on supply. Food comes in, energy gets distributed, workers build things, the city grows, expands, consumes. But every great city also needs a sanitation system. Garbage accumulates. Old machinery breaks down. Damaged structures pile up in corners nobody visits. If the city never stops consuming long enough to clean, those damaged structures don't disappear. They stack up. They interfere. Over time, they begin to corrupt the function of everything around them. Now imagine the sanitation crews have one specific trigger. They don't activate when food is flowing. They don't clock in when energy is abundant. They only begin their work when the city goes quiet, when supply stops, when the system detects, with remarkable precision, that resources are scarce. That trigger is the absence of food. And here's where the science gets genuinely strange. Your body doesn't interpret fasting as deprivation. It interprets it as a signal. A cellular message that reads, clean house, conserve energy, repair what's broken, and prepare for survival. This is the ancient logic buried in your biology, long before grocery stores, long before 3 meals a day was a cultural standard. Your ancestors went long stretches without food, not by choice, by nature. And during those stretches, the body didn't collapse. It activated. It cleaned itself. Autophagy, from the Greek, auto, meaning self, phagy, meaning eating, literally self-eating. The mechanism was first described in the 1960s by Belgian biochemist Christian de Duve, the same scientist who discovered the lysosome, but it was Japanese cell biologist Yoshinori Ohsumi who cracked the genetic code behind it in the 1990s, earning him the Nobel Prize in Physiology or Medicine in 2016. His work revealed something that changed how we understand the entire relationship between fasting and cellular health. Here's the core biology, stripped of jargon. Inside your cells, there are structures called autophagosomes. Think of them as biological garbage bags. When autophagy activates, these bags form around damaged proteins, dysfunctional organelles, misfolded cellular debris, anything that the cell has flagged as broken or unnecessary. The autophagosome then fuses with a lysosome, a cellular acid chamber, and the contents get broken down and recycled. Amino acids, energy, raw material, reused. The cell is eating its own waste and turning it into fuel. Now here's the critical question, the one this entire video is actually about. How long do you have to fast before this process meaningfully activates? And the answer, the real, research-backed answer, is more complicated, more nuanced, and frankly more demanding than most fasting content will ever tell you. The primary inhibitor of autophagy is a protein complex called mTOR, mechanistic target of rapamycin. Think of mTOR as the growth signal. When mTOR is active, the body is in build mode, constructing proteins, growing muscle, processing nutrients, expanding. When mTOR is active, autophagy is essentially suppressed, and mTOR gets activated by one thing above almost everything else: food, specifically amino acids, particularly leucine, and insulin spikes from carbohydrates. Every time you eat, especially protein or carbs, mTOR turns on and autophagy turns off. It's not gradual, it's a switch. So the question becomes, how long does it take for mTOR to quiet down enough for autophagy to meaningfully engage. Here's what the research actually suggests. After your last meal, your body spends the first several hours in a postprandial state, digesting, absorbing, distributing nutrients. Insulin is elevated. mTOR is signaling. Autophagy is at its baseline, essentially idle. Around the 12-hour mark, insulin levels have dropped significantly in most people. Liver glycogen is beginning to deplete. The body starts transitioning, slowly, into a catabolic state. Autophagy begins to increase, but researchers are careful to note, baseline upregulation is not the same as significant activation. The studies on fasting and autophagy in humans, particularly work by researchers at the University of California and separate studies published in Cell Metabolism, suggest that meaningful, measurable increases in autophagy markers begin appearing somewhere between 18 and 24 hours of fasting. Let that land. Not 12 hours, not 16, 18 to 24. But here's where it gets genuinely interesting, because the timeline isn't the same for everyone, and the reason why tells you something profound about your own body that most people never think to ask. Your personal autophagy timeline depends on something almost nobody talks about, your metabolic flexibility. If you are metabolically inflexible, meaning your body has become overly dependent on glucose, struggles to shift into fat burning, has chronically elevated baseline insulin levels, your autophagic response may be significantly delayed. Your mTOR suppression takes longer. Your body resists the transition. Conversely, people who regularly fast, follow lower carbohydrate diets, or have higher baseline insulin sensitivity tend to enter autophagic states faster. Some research suggests these individuals may see meaningful autophagy upregulation closer to the 14 to 16-hour mark. In other words, the more metabolically healthy you are, the sooner your body allows itself to clean house. There is something deeply poetic and slightly uncomfortable about that, because it means the people who need autophagy most, those with the highest metabolic burden, the most cellular damage, the most accumulated biological noise, are precisely the people whose bodies take the longest to activate it. And there's one more variable that changes everything, one that researchers stumbled onto almost by accident, one that reframes the entire fasting conversation. We'll get to it in part 2. In 2019, a research team at the Salk Institute for Biological Studies published findings from a time-restricted feeding study that created a quiet tremor in the scientific community. What they discovered wasn't just about when autophagy activates, it was about what amplifies it. The missing variable wasn't fasting duration alone, it was the combination of fasting duration plus the depletion of a specific cellular energy sensor, AMPK, adenosine monophosphate activated protein kinase. Think of AMPK as the cell's fuel gauge. When cellular energy drops low enough, AMPK activates. And when AMPK activates, it does two things simultaneously. It suppresses mTOR and directly stimulates autophagy. Here's the critical insight. AMPK depletion takes time, real time, and it's accelerated by physical activity during the fasted state. This is why researchers studying fasted exercise kept noticing disproportionately elevated autophagy markers. It wasn't just the fasting. It was the fasting combined with movement. Because movement drains cellular ATP, drops energy availability, and triggers AMPK far faster than rest alone. Translation: a 16-hour fast with a morning walk may trigger more autophagy than a 20-hour fast spent lying on a couch. Your body is not responding to the clock, it's responding to the energy state. The clock is just a proxy. This changes the entire equation, and it raises a question that researchers are still quietly wrestling with. If autophagy is governed by energy state rather than pure time, can we manipulate that state faster, with greater precision, than simple food avoidance? The answer appears to be yes. And the mechanism behind it is where the science gets almost uncomfortably elegant. Let's dismantle something. There is a belief, widely circulated, enthusiastically repeated, that the 16 to 8 intermittent fasting protocol reliably triggers autophagy. Eat in an 8-hour window. Fast for 16. Autophagy activated. Health optimized. Done. This is not what the science says. For a significant portion of the population, especially those eating high-protein, high-carbohydrate diets within that 8-hour window, especially those with any degree of insulin resistance, especially those who aren't incorporating movement, 16 hours of fasting likely produces only marginal autophagic activation. Detectable in blood markers, perhaps. Functionally meaningful? The evidence is thinner than the fasting influencers would have you believe. Researcher Walter Longo at the USC Longevity Institute, one of the most cited scientists in the fasting and longevity space, has been notably measured about short-term fasting windows. His work has focused more heavily on prolonged fasting, 48 to 72 hours or cycles of the fasting mimicking diet, as the threshold where autophagy produces the kind of cellular renovation linked to actual health outcomes: damaged cell clearance, immune system regeneration, metabolic reset. The uncomfortable truth is this: mild, daily 16-hour fasting is better than nothing. It may produce real benefits at the metabolic level: improved insulin sensitivity, reduced inflammation, circadian optimization. But if the specific goal is deep autophagy, the kind that clears misfolded proteins linked to Alzheimer's, the kind that strips precancerous cellular debris, the kind that researchers associate with genuine longevity extension, the timeline extends considerably. And here's what that means for you personally. The version of fasting you may have been doing, telling yourself you're triggering autophagy, is likely producing a fraction of the cellular cleaning you imagined. That's not an attack, it's a recalibration. Why does this matter beyond biology? Because your brain is involved in this process far more than most people realize. Autophagy doesn't just occur in muscle tissue or liver cells, it occurs in neurons. Studies from researchers at the Buck Institute for Research on Aging and separate work published in Nature Neuroscience have shown that neuronal autophagy plays a critical role in clearing the protein aggregates associated with neurodegenerative disease: amyloid beta plaques, tau tangles, alpha-synuclein clusters. These are the biological calling cards of Alzheimer's, Parkinson's, and other age-related neurological conditions. And here's the implication that nobody in the mainstream fasting conversation is saying clearly enough. Your brain's cleaning system, the glymphatic system during sleep and autophagy during fasting, may represent the two most powerful anti-neurodegeneration tools available to you right now, without a prescription, without a supplement, already built into your biology. But they both require the same thing: extended periods of low energy input. Sleep runs the brain's fluid drainage system. Fasting runs the cellular repair system. And in a culture that eats constantly, sleeps poorly, and glorifies productivity over recovery, both systems are chronically suppressed. The data suggests this may be one of the most expensive biological trades modern humans make without ever realizing they're making it. Here's the reframe. We have spent decades thinking about food as the primary lever of health: what you eat, how much you eat, the ratio of macronutrients, the timing of protein, the glycemic index of carbohydrates. Food has been the obsessive center of the health conversation for generations, but the science of autophagy quietly suggests something that cuts in the opposite direction entirely. What you don't eat, and for how long, may matter as much as what you do, not because fasting is a magic cure, not because skipping meals is virtuous, but because the body's capacity to repair itself, to clear its own damage, to run its own maintenance cycle, is a function that exists in the absence of feeding. It is built for the gaps, designed for the silence between meals, calibrated, over millions of years of evolution, for the reality that food would not always come. The body never evolved a repair system that runs while it's eating. It evolved a repair system that runs while it's not. And here's the final thought to sit with. Yoshinori Ohsumi, the man who won the Nobel Prize for unlocking the secrets of autophagy, was once asked what he personally took from his decades of research, what the single most important implication was. He paused, and then said quietly that what struck him most was not how powerful autophagy was, but how easily it was disrupted. How the smallest, most casual act of eating was enough to shut down the entire cellular cleaning process within minutes. Every bite you take is a conscious vote, for growth or for repair, for building or for cleaning. Your biology can only run one mode at a time, and the question the science leaves open, the one no study has definitively answered, the one that may ultimately be the most important question in longevity research, simply this: in a world designed to make you eat constantly, how much of your life have you actually spent letting your body fix itself?